Tara, um, principal engineer at Microsoft. I focus on IoT, robotics, and AI on robotics. I'm supposed to talk about myself, right? Okay, so I'm in grad school at Georgia Tech, and I'm failing my robotics ML class because I'm not making it to lab because of work. So in all fairness, I'm not failing it because I don't know what I'm doing. I'm failing it because I can't show up, which is kind of funny because that's my whole thing. So that's what I'm doing I'm supposed to be doing my thesis on. So it's kind of funny. All right, vulnerable moment. I am failing the class that I actually should be able to breeze through. Kind of need to show up. That's what I do. That's who I am. I'm always here at Refactor, and typically, I try to bring all of my gadgets. So when I say I'm a hardcore IoT person, if you saw my desk, it is cluttered with different types of robots. I got the new TurtleBot 4 coming. I'm very excited. It just didn't come in time for me to have it running around the floor with you all to the house. But hopefully I'll have time to show you my robotic arm. And what this is robotics for everyone. Okay, so for those of you that are disappointed it's not IoT, let me just say this. Robotics is the next step up IoT, and we'll get to this. Now that we now can compress models and other things down, I can now run ROS on microcontrollers, which means there can be a robot in everything, which for people like me makes me very happy. So that's what we're gonna talk about. Since it's a small crowd, you guys can tell me really what you want me to do, because it's not that many people, so I don't have to yell out and do anything. We can just kind of make this our own. So that's what we're talking about. So did anyone not think this was gonna be robotics? They like, oh crap, I'm in the wrong place. Yeah, you good? You okay? Feel free to exit stage right. I won't feel bad at all. I'm going to definitely talk about robotics. Okay. I'm not gonna ask what that reason is. I'm gonna keep. I'm gonna smile and wave and put on my glasses and try to seem intelligent and keep going. All right. So what are we gonna talk about? First, we're gonna talk about what it means to develop for robotics, right? And what this ROS thing is. And yeah, the world was very different before ROS existed. Now we're gonna build something. How do you start building with robotics? I'm a C++ person. For all of you all that have visceral reactions for that, you can also code in Python. Feel warm and fuzzy about that. It's okay. Even though you should come over to C++, it's not that bad. Just whatever. But it's a Python thing. But I can do things much faster than C++. So sorry, that's what y'all gonna get today. I will maybe I'll do Python. I don't know. I'll be struggling. We'll see. And then I'll just get into some code of what it's like to do this and how you can do different things. And then we'll just kind of go from there. I have my simulation up since my TurtleBot 4 didn't come in time to follow you around the room, but we can simulate some things and see how this whole setup works. It's not as daunting as it seems, not until you get into URDFs, and we won't talk about that. So we're gonna be good. All right, so let's get started. First of all, what is ROS? Now, before you all that goobly gop on the screen, let me tell you what happened before we had this. So before we had this, everybody and their grandmother and their cousin and every relative and whatever who wants to do robotics had to come up with their own way of having whatever OS you were running, run on this. And then whatever library you wanted to do, oh my God, you came up with it by yourself. There was no, you guys love your little package managers, don't you? Yeah, no, that didn't exist. Everyone was going for broke, and so it was super hard to build robotics. So after you finally got all of these pieces, I'm actually glad this is here. So actually you got all of these pieces together. So all of these pieces are a combination for this one, and some of them the bigger ones too, the CUDA arms, of microcontrollers, MPUs, and then a master slave. After you finally put all this together, and somebody wanted to replicate this, good luck with that. So now we have ROS and we have URDFs where I can take this model and I can pass it to you and then get generated where now we can have robotics get spit off the line. But then, even if it did, millions of dollars worth. Like this robot here, this is cheap in robotics terms, was only $1,400. Now, you like, that don't sound cheap. But before, this robot would have been, just for this research, $6,000. So robots are getting cheaper. And now it means it's more accessible to everyone. So after you got past that, $1 million of building your robot, so like for instance the Spot, which we have in our office, which is super ugly, but it's super fun to play with, but it is creepy. Before we got it, during this period of time, we as Microsoft really would have had a challenge acquiring a Spot. That's how expensive they were. So after you got this $1 million, $1 trillion robot, now you got to figure out how to program it. And again, everybody was going for broke. So now I can't even share with you your code. There is no package manager. So someone finally in 2007, and think about it, that's not too long ago, came up with ROS. And this is what I hate. Well, in IoT, it's kind of funny. So there's RTOSes, there's ROS. None of these are operating systems, even though that's said in the name. Forget that. It's not an operating system. This runs on Linux. We have something now that runs on Windows. Okay, just FYI, I know we're for Microsoft, but I'm a Linux person, so just bear with me. And so now you have this robotics operating system. It is not an operating system. It's a framework. And you run this framework on operating systems, so it's like a middleware, and now everyone can share code. So that whole story means now you have all of these coming out like Prego. It's like it's going for broke. You pick your poison. Well, what happened with robotics that is fun for people that are roboticists? Now we have robotics, ROS 2. Why is that a big deal? How many people in here are cloud people? Nobody. One person. We're just going to be friends together because that's all we have, one person. Okay, for those of us that are cloud people and all we think about is scale and how I'm going to run this in a distributed system, now let's talk about, so we was already hard. We finally got ROS. Okay, we're cooking with gas robotics. We kind of need to connect to the internet, right? Yeah, cool. So I'm going to just go around with a USB, and you think I'm playing. USB stick. Anyone here done robotics at all before? Yeah, okay. You went around on the BMW floor, because I actually was on it, and I was like, okay, that is not going to scale. And then I was like, oh, yeah, us running around with USB keys, and yeah, no. And then now you want this data to go somewhere. But the data couldn't go directly from the robot anywhere because that didn't exist. With ROS 2, what has happened now, instead of us having to stand up all this stuff to get things to the internet, we now have a middleware that directly talks to the internet and does normal protocols. So while robots look really cool, it has been painful for those of us who have been in it for a while. Now what does it do? We got distributed systems now. It's multi-language. It wasn't before. So again, Python. For you MATLAB people who are suffering through grad school like me, and I really hate MATLAB, but they really seem to love it there, there's a flavor of it there, and then there come up one for Java, for Java people. Now, here's the caveat of it. They don't have as many libraries, but you still have Python, so you're good. It's lightweight, and now it's open. It's complete open source. So you have indexes, you have navigation things. You want a drone and you want to program it, go online, go on the ROS site, put in the drone you have, and you will have your drone flying around, taking pictures, and have ML models. That didn't exist in 2007. So the concept now of ROS, now I gave you all the history. Let's talk about what's the difference of it. So now we're talking about ROS. Of course, we have to be stupid, though, because we can't just keep the names the same across the different versions because that would be too much like right. So we changed them. But let's talk about what they are as concepts. And everyone is angry about it, but it is what it is. So when you start with ROS, there's a concept of, which this is not the most inclusive, but okay, it still is there, which is why they try to change it for 2. You have a concept of master nodes, topics, messages, and nodelets. And you're like, that's great. You have those words on the screen. You haven't told me what they are. 1 second, I will get there. So they got rid of nodelets, and they have nodes over here. And we'll get to what those are, but they are synonymous. So we got master nodes, topics, messages, and nodelets. And so how this works is you got the master. It is the main, it's the brain kind of thing. And all these nodes are not quite the nodes you think. So you would think, right, that a node would be one of these. It's not. So this is a gripper. This has a separate chip in it. This has an M4 chip in it. Oh, God, sorry. I talk in chip language. I will not do that to you. But these have different chips in them. And you would think those are the nodes. They are not. What the nodes are is I want to publish messages out somewhere, and I want to receive messages in. But the messages are not going out to the internet yet. This is where this gets confusing. The messages are getting sent from this node that is here to any one of these chips that is listening, because now I want to send a message to the node that says, turn it to the left, whatever that node is named. And it sends it out to it. It is a synchronous, it's a pub sub model. And then it'll make my gripper grip something. I can send it so that messages has the torque for it, which ends up being very important because this is a replica of a CUDA arm that is much bigger than me and would take up this desk. You don't want that to swing around and knock you out. Trust me, it is very dangerous to be around robotics, which is why ML is starting to become important. So you have this master, and this is the communication between those nodes, processes. Think old school operating systems. Yes, we're back at processes. So your nodes, then you're going to build, and they have just a single process. All I want this node to do is to make this gripper squeeze in and out. That's it. And that sounds so simple, doesn't it? Yes, no, it's not. But this is what I'm going to write. So now I have this node, and this whole process, all it does is just squeeze this thing. But how do I tell it that? How does this message interpret that this torque means, because there's a bunch of pieces in here, this torque means that I need this torque to go in this much, squeeze this much, topics. So does anyone know, probably only me, but it's fine. I'll just be alone in this. Does anyone know what MQTT is? Anyone? Anyone? Yep, no. Okay, so MQTT is messaging, well, it doesn't really stand for anything now, but it did when it first came out, with messaging, queuing, transport, telemetry, right? And the reason why that's important is every time you do anything, ring device, it's sending messages back and forth. It needs to send them super fast and really small. That's a protocol that sits on top of TCP/IP for IoT. Now, those have topics, and those topics says keep value pairs, gripper, torque, 45, and that's what sends, and I read the node and it goes before. So if you look at the screen, I have this pub sub model where I'm gonna push something in a topic. Torque is the topic, and 45 or whatever it is, that's not quite the value, but it's fine, is the value. I read it. My subscriber, any one of these that care, it just so happened that this process is the only one that cares, the gripper. It says it. It may send something back, it may not. Or I can then, that arrow going out, he was like, I can't see the rest of the thing. That arrow going out just says it can go anywhere else. I guess that wasn't as creative as I thought by doing that. But that, I can then say, hey, this message can say, I'm gonna have in this message definition of this topic that it's a number, the width is whatever, and the string is whatever, and then I can have code that does something with it. So that is really the gist of robotics. I mean, super simple now that we have ROS, so that didn't exist. So you have these topics have messages, and then you take these messages and you can hopefully make your robot torque move the right way and not take somebody's hand off. That's always a good thing. And so you have this concept of nodelets, because I want to reduce the chattiness, because it's going back and forth a lot, and we're talking about millisecond response times you need. So you can have like these nodelets so the processes are not so heavy. That's the gist of it. Okay, we got that, great. Now, the concept of ROS2 is the same, we just took out master. I don't know, we just decided. So nodes, there's now just a main node, and the rest of them can be nodelets. There you go. Now, how do you set this up? And this is what we're going to do in a minute. And I'm just gonna kick off a VM to show you how it runs, because it takes 15 minutes, and we're not gonna wait for 15 minutes for this to do it, but I'll just show you how the setup goes. You're gonna set up what they call a sources list, and you're gonna set up keys, and you install these ROS packages. Now, ROS has these really interesting names: Noetic, Galactic. I don't know how Hawkbill came out this week. We were all in space, and now we're Hawkbill. I don't know, but we have these interesting names. They usually are based upon space. The last one for ROS2 is Galactic, right? So you set up these distro packages. Now, here's the crazy thing about it. If you're running something with your computer, and let's say you're running Linux 2004, right? You don't go, oh, 2004.6 is come out. I have to now create, this whole different thing. You just hit upgrade, right? Isn't that what we do? Or Windows, if whatever you work in. Yeah, the operating system of your choice. Mac, you just go, oh, brew and whatever. You don't go, oh, wait, I have to completely switch to something else. In ROS, you do. So if I'm running between Noetic and Galactic, I literally have this sources thing where I have to source the script that says, now I'm in this environment. Kind of sucks, but again, based upon where we came from, we're not complaining. But you have to do that each time. And it's kind of weird. In each batch terminal, and I'll show you in the simulation, I can run in each batch terminal a different one. But if I don't source it, your robot will have some challenges. So that's the only kind of quirky thing. This exists whether you're doing C++ or Python. It's just one of those quirks with it. You got to source. And all of a sudden, you're like, I know I've installed ROS. I know it should work. But yeah, no, what's happening? You have to source this. The other thing is, so ROS came out obviously initially for Linux. We have a version for Windows. And because I work for the company and I have coworkers here, I will not talk about that version for Windows, not at all. I will attempt to be somewhat corporate good citizen, so I won't talk about it. But there's one out there. Use at your discretion. Okay. So you can now just, again, package manager ROS, and then you have these commands, like there's this ROS bash package that will run for you, and now it sets up in your bash RC, and you're good to go. I won't do it. Okay. Now, once you do that, remember I said you got a source, so we're going to just do this in a second. I'm just going to kick it off. And these are another concept that's kind of weird when you sell ROS. So there's this build system with ROS, and now we changed these names. This build system is named Catkin. It's the one that's not quite out yet. Qualcomm is. We have these real build systems. Now, if you're in C++, you live in CMake. I know, it's okay. I live in CMake. Python, you don't have to do this, but it runs the Catkin system. Why? Because Python still compiles, under the covers is C++ compiler. You still got to come through as C++ people, but you don't know it, so you're fine. And so this new build system is called Catkin, and it's specifically designed for ROS. So once you load your source, so you hit the setup bash that has to run each time, the next thing you have to do is set up what we call this workspace. So I'm going to switch really quickly just to show you. Again, we're not going to run this long because there will be no way I could do all of this. Let's see if this actually came up because, we're restarting because I installed it. So we won't wait on that. We'll wait till it comes back. I'll come back to that. I'm absolutely not going to wait on that. So let's go back here and I'll just come back to it. So now I have to set up what we call a workspace. And this workspace is where I'm going to set up this robot YAML file. So cloud people, if you like YAML, don't like YAML, I'm sorry, you kind of do this. And I have to then say, okay, I want these packages to run with this. I want these things to happen. So this is how you kind of set it up. Of course, we change everything. So now it's Catkin build versus Catkin make. But once I set up my workspace, I got to be able to build these packages. Now, this is where user participation is good. I just need a few people to tell me what you code in and what you typically do on a daily basis. Okay, so do you build packages? Are you just in a certain environment? What do you do? So in your migration of tables, do you have to pull in any specific library for something? Let's say you wanted to do, okay, right? These packages that you do are the same thing. The difference is you get to build your package. That's the only difference. So you wanted something special. Let's see, when I was at AWS, what were we doing with databases? We were doing GraphQL. That's what we were working on. Oh, you guys smiled then. Okay, so databases. So y'all get hyped by databases, not robotics? Come on, really? This is the room I'm in right now? Okay, whatever. What? All right. So GraphQL, if you were building that and you wanted to use that for what you were doing, you would be able to build your own version of GraphQL. And so these packages, either you can get them from the ROS index or you can build them yourself. And so when you set this up, you do it. The ROS2 system is Qualcomm, so of course we changed the names and the functionality is the same. But then they decided to take it a step further. They don't want you to use CMake anymore. They made up something else called Admint, which is like a combination of CMake and something else because why not just make it difficult? And then once you do that, you just compile. Now this is C++, I know, bear with me. But you still would run a Catkin config for you all and a Catkin build. You just would do it Python. Instead of Catkin build like me, you would do it Python. All right. that is the Catkin system. And now at this point, you guys pretty much know everything you need to know to build code with robots. Like seriously, I'm gonna have a source folder. It's gonna do a build folder. You shouldn't touch that. Just shouldn't touch it. And then there'll be a dev folder where all those targets you do will run. They're gonna, once you run this build, it'll do that part for you. And then the other part, you know, you can muck around and do whatever. If you happen to just be courageous and go in the build and really muck up stuff, you can hit a Catkin clean and it will try to help you, but good luck to you. And then the last thing you want to do is then you want to test that this actually works. And so to run your application on your robot, it's called a ROS launch. And obviously you can have a build that when it kicks off, the robot comes on, it runs this ROS launch, and then it can swing around and do whatever X, Y, and Z. And you can not only just run the launch file for the whole robot to run, if you want to test, you can say, I just want to run one package, and that has a separate launch file. So this huge YAML file that you're talking about will run multiple packages and run the launches. All right, last thing to know about it, this is the YAML file looks like as it's launched. So I want to have a range of my world. We won't get into, because I won't have time, we won't get into the ML simulations of it. I'll show you Gazebo, but we won't get into that. But I want to have this thing run multiple packages and do different things. So I'm gonna say, hey, when you start up my robot, I want you to launch this empty world launch, which is a simulation. So I can have my LiDAR as just a thing that does, how to explain it? Like, thank you. I was trying to how can I say this without going through the whole acronym? So it's gonna go through the light and be like, oh, there's something there. And then the camera will try to make it 3D, whatever, and not try to knock people down. And so I wanna launch that in a world and simulate it. And I want this to kick off when the robot kicks off. So these are 2 launch files that'll come. That's a package that's associated with it. And I'm gonna send some arguments in that say I wanna use some physics engine. And that's what that looks like. And so now we're going to get into ROS code. So at this point, you guys should at least know, hopefully, if we did this right, what a subscriber and a publisher is. Maybe. Okay, cool. And then what the parameters are, because I just showed them to you. Just smile and wave if you didn't remember. And then what a node is. So we should be somewhat good with that. All right. So let's go. Hopefully this is rebooted. And let's go look at just kind of what I talked about right then about sourcing this, getting this up and running. We're gonna cross our fingers that it's there. Oh no, it's still thinking about it. Let's see what happens if we give it like 5 seconds. And if not, I will have to go to the simulation, which of course is telling me due to my inactivity, your simulation session has closed. Please restart. So one of these is gonna come up because I did not spend all this time setting up a simulation for this to happen. So one of these is gonna come up. We're just gonna put this out there. Mm-hmm. Mm-hmm. Great question. So yes, depending on what robot you're running, it can run Bluetooth. But like I said, the world has changed. So now I actually can run an RTOS with ROS on it. So it may be running an RTOS, which is not quite an operating system. It's really a glorified task scheduler, but it might not be running Linux at all. So this one particular is running, I think I have Yocto running on this one, right? But you can have the bigger ones, maybe full Linux, running, whether that be Debian flavor, Fedora, etc. Or the smaller ones, like I said, are running RTOSes. So RTOSes are, if you've not heard of RTOS, real-time operating systems, which really are not, they run the little small devices that you see in your Ring device. Usually I know this is weird, but usually I have microcontrollers in my bag, and I don't think I have them today, which is kind of weird that I don't have it, which probably is weird that I do have them, but okay. So those don't run full operating systems. They're too small. So I now can run, for instance, now there's this concept of micro ROS, which I'll get to, because hopefully this will reboot and we'll actually be able to log in and stuff will happen. Yeah, we'll see. If not, I'll just show you the source on the other screen. Correct. That runs that little small chip runs FreeRTOS. So now what we've had now is because they have ROS small enough, I can run on that ESP32 or 8266, I can run ROS. Why is that important? That means for this robot, for those of y'all, I will try not to do chip speak. There's small chips in each of these. And so now I can actually have RTOS running on here with ROS running separately on this. So now I can put an ML model on this where it detects when this torque is wrong and not swing and knock somebody out the way, right? That actually happens a lot. Y'all are laughing, but I'm like, people are actually maimed a lot because of it. So it's a thing. Like it's a thing. And trust me, you don't want to get hit by a CUDA robot. Yeah, my arm still hurts, and it was years ago. So yeah, you don't want that to happen. Let's see if we can get this to kick off. Maybe not. So let's take it too long. So what we're gonna do while that's thinking, I'm gonna switch over to my simulation. Hopefully, let me drag this simulation on. Maybe I'm gonna drag it if my mouse. Okay, let's see. You can't have more than one desktop open. Really? Let's try this one then. By the way, if you guys ever want to do this, this is a cool thing. It actually is running, ironically, Visual Studio Code. But it is a cool company that I worked with called Construct 2. And they give you a full simulation run thing and a notebook. So some of these notebooks I helped to develop, and some of them I didn't. But you can go and literally, some of them are free and run a full environment. Like you don't have to have this TurtleBot 4 is the one I was waiting to come in so I could show you guys traveling around. But it's a full simulation, and everything I would do on this, I would do on the robot. So let's see if can you guys still see this? Let me move this out of the way. I don't know why it keeps putting that notebook back, because we don't need the notebook. No. Crazy thing is, I worked at AWS when we were running their ROS implementation. Why there is a RoboMaker now is because of Ben Keogh iRobot. I was actually there, and that was one of my fun projects. I got to work. I got one of the first ones, which did look nothing like it does now. But now, okay, so you'll see that it says ROS launch will exit. So remember when I said that when you're launching these things, you launch with ROS launch, right? So let's look at one of these. So the first thing I'm gonna do is, I know I'm doing VI. Just bear with me. We're gonna let's see your bash RC. Yeah. Oh, come on, man. Okay. You can't see that. It would be blue. It would be blue. Because that would be too much like right for you to actually be able to read it. I mean, let's see if I can get down to the end where it's something you can read that you'll see. Because this is already sourced. Yeah, no, you can't read that. Can you read that? I can't read that. Yeah, that's not helpful at all. Let's see. That's okay. Okay, we're gonna get cozy. Just like it's just too much like right now. Okay, well, let me just read what it says while we're doing this, because obviously we have some challenges. So anytime this run, it's going to export some values for you. So Gazebo is your simulation engine. Yeah, that didn't really. Okay. Well, let me just read it because I have it on the screen. So luckily, I took a screenshot of it because that's interesting as well. It exports values out for ROS. Put it in your bash RC. If it was Windows, it would put it in your registry and other things. And it is like, what am I going to run my simulation in? So this simulation here is Gazebo. It's one of the more popular ones. If you do gaming, Unity actually has one as well. And if I come out of this and I run launch, because remember I said that the launch is what you do to kick this off. I want to do this turtle bot. I want to do a telop. And these are two different launch files, right? The turtlebot telop, and I'll show you the source for a minute, and then the keyboard telop. And so let's talk about what it's doing. So this telop, what it's doing is I'm having it move based upon what keys I push the robot, okay? So I'll show you the code and then we'll actually run it. And so what it's doing is if I push a U, it's gonna go in a circle. If I push, let's see, an I, it's going to move around. So I have it like it's think about of a matrix. U will be back into my left, your right. O will move forward. I will go try to find its way in the middle. So you're gonna see, I'm just gonna put, so I got U, I, O, I think J, K, L, some numbers, whatever. I just kind of, and so that's what that is doing. So remember I talked about the launch files, wherever my mouse went, because that would be great. Okay, so here's the source for this, that it's of course not showing because that would be too much like right, which means this died as well. We're just doing so good today. Let's see if we can launch this and see at least if the code is still, because it is compiled. Yes, okay, that's great. All right, so let's look at this. Can I make this bigger? Yes, lovely and divine. Great. All right, so here we go. So I launched this telop, which I have no clue why it's not showing the code, but I'll restart that in a minute. So I'm running Noetic. That's the distro I'm running. The ROS version I'm running is that, and you see these are two launch files of the code that some kind of way I'm gonna relaunch Visual Studio Code and it's gonna show you. And now those launch files are running because I built it, and I'm running this in Gazebo because it's a simulation. So once I shrink it down, you'll see. So if I'm moving around, like I said, I have the things to move around. And so I can increase the speed that it goes. I can hit the space key so it doesn't hit anything. So we're gonna see if this actually works. It was working before. Cross your fingers. All right, so if I hit U on this, yes, it is moving. That's good. That's a good sign. If I move J, it moves around in a circle. So remember, if I do K, and sorry, it's a little bit of delay because it's a thing. I move the opposite way at L. If I do M, it makes me go forward in a direction in bigger loops. If I want to adjust otherwise and back up. So this is the code running, and there's two launch files. One to map my keyboard to what I want to do for the robot. So let's say if I was on a real shop floor, I could be sitting here as a person and say, okay, pick up the car and go for it. So we're going to try to show you this code because I'm going to relaunch Visual Studio Code because that's weird. So wait, so I see my setup files, but I don't see the code. Okay, it's fine. It's fine. Yeah, let's see what's happening here. No, of course. Which one? Here? Here? Oh, let's see. Let's see if that. No, that means it's frozen. But let me show you the launch files while I'm in here and the setup bash that you should have been able to see in there. So this is the line that it's going to run to say, okay, I want you to set up those bash source and cat can setup directory. When you install ROS, it sets this up for you. The local setup is going to be, okay, where do I want this to run and where do I want to put the initial code to set up my arguments? These are the things I talked about, the arguments and things of that nature. Then this is, and it will do it for both Z shell and normal bash shell, so don't you worry, you guys cover it. And then this environment one just kind of sets up your typical environment because I'm using Linux. So that's this. That's weird that I can see that, but it's not showing me the code. Like, that's the weirdest thing ever. And then obviously when you build, this is when it builds all and generates the files for it. How do you build without code? That's how I know this thing is crashed. I mean, that's kind of impossible. I mean, I just usually it's not how things work. But anyway, so let me bring this back down. So what's happening now is this is now running those two launch files, tying those two together, and the nodes, we talked about the sub pub, is saying, hey, which is why I wanted to show you the code, I have a speed that's in a topic, and then as I push things faster, you see I can increase the speed by 10%. So I started off with my speed being at 50, but 50 is relative for the simulation, and so I can increase it, and that means a topic gets sent across to do it, which is why uncoming in one line of the code, you can see actually it going across, but it's hard to uncomment code when you don't see it. But we'll get to another demo, and hopefully my code will show up. We're gonna cross our fingers. All right, so let's just go back. Let me kill this so it won't be running in the background. And then I'm gonna hope while we go back that this will finally come up and run so that I can show you the setup. So we're gonna, what? No, I don't wanna upgrade, but I'll come back to you. All right, so let's go back quickly to the slides. My hiccups have taken a lot longer than I wanted to. So I have 3 minutes to go through a bunch of stuff. So I'm gonna start skipping stuff and talk about just some code. So let me just start some key things. These things are the same in Python. You're gonna have a ross.init, you're gonna have a ross.ok, you're gonna have a ross info for logs, you're gonna have a ross spin once. And that just means how do you process your messages with callbacks. And so these are going to be like the ways that you communicate and you build. It always has to init. No matter what happens, you have to do an init. The next thing is we talked about these nodes. So remember, these nodes are separate processes. So obviously you need to have, how does this process get infused with the other processes? You're gonna have a namespace for your process. Again, this is C++ code. Rest assured there is a ross.node handle in Python, you're fine. I'm gonna have a global handle so the master or the node knows about it. My namespaces, I can organize these things by namespaces. So all the topics for movement may be in some namespace that said move it Terra. And all the topics for, let's say I only have topics that are related just with this gripper that has nothing to do with the rest of this stuff moving. I can have namespace for that, or I can just literally just send a topic. So the reason why this is important, because trust me, when these things start flying at millisecond rates, you're gonna wanna know where it lands. Some of this is definitely C++, so there's obviously a standard out. It's there in the error that you have for Python. It's just gonna be logged a little different than how I would do. You're still gonna have the severity levels, and you're gonna want to see these things on the screen. And then last thing I'll just show you, because this part is like literally robotics 101. You're always gonna build a listener. I don't care what you're doing. I don't care if it's a BMW car that has this as running ROS or the iRobot, you're always gonna have a listener because you always need to know, hey, as a process, I'm waiting for something to tell me something. So you're gonna build this code a trillion times over. And so this is the base way you do it. Your listener is always gonna be what we call a subscriber. It is going to be listening for data to come across a topic. It's gonna need a handler that, because this is asynchronous, it's gonna need something that says, I wanna kick off this callback when this happens. So you see, this just happens to be named Chatter because I really couldn't think of another name yesterday. And so that you're gonna have a subscriber of this. This code is going to happen all the time. Now in C++, we have a process callback called spin, because if you're parallelizing your threads, which you don't have to worry about in Python, you need that, but we won't get into that. And then you're always gonna have a publisher. This publisher can run, why can't you see my code? That's a black box. That's a black box. It is a black box. I see it's a black box. And there's words there, and the words were white. So why? What's going on here? So, but, okay, it's fine. It's fine. It's fine. What? Just, I didn't, okay, it's fine. It's fine. My new meme is the dog that has the cup and everything's burning. That is my new thing for that is my new thing for everything. Today is one of those days where it's fine. It's fine. You're gonna have a publisher, and this publisher exists again across languages. Because whether you're the master node or other nodes that you need to communicate amongst each other, you need to punch messages out. So let's say I have an ML model that detects my ball, and I don't think I'm going to have time to run that ML simulation, but I will post a video of it because obviously I don't have time. But I may have either a LiDAR or a camera on this that can look at pictures and build 3D models of them. Actually, what my class is talking about that I'm failing that my thesis is about. Great. So you want to pick up the red ball, the blue ball, the whatever, and you want to detect that whether or not the ball is fully seen. So let's say once I do that and I have detected that this is the ball, I need to say, hey, this node that's running on this particular chip, I need you to bend down, right? Because this is not going to do it. And then obviously that's not going to pick up the ball, so I need to send a message to this other one that says, okay, you bend and by this percentage, and there's algorithms for it. And then once it gets down, I want the gripper then to squeeze the ball. So how you do all of that literally is messages, literally just key value pairs. Streaming key value pairs is literally that simple. And they're published in what we call a message. So my message may have a key value pair that says something about this node, something about that node, and now I'm dropping my screen. And then it might have something about the gripper, and that's my message. All right, so moving on, because we're now out of time. The last thing I want to tell you about this, and then if anyone time, I could just let you all come play with the simulation since nothing is working. You package this into these packages that you build. So the node that I would have that would detect the ball and then gripper, that might be like my detection package. The one that I had, if this had wheels on it, like a turtle bot, maybe another package that I want to do for motion. There's a major package that's called Move It that most people use. I may have customized that. And then you have these algorithms that you create for it based upon what you're doing. So the last thing I can do, and this becomes really important, is you obviously don't know everything that is going to happen with the robot at the robotics time. One of the big projects that's coming out of DARPA is how do you prevent people from dying from going into subterranean areas and can't breathe, or miners who have been stuck in something collapsed. We would prefer to put a robot in there because they're not alive. They're not sentient. We have a long time to get there, by the way. People keep asking about it. We're not anywhere close. You're okay. So we wanted them to go in there and not us. And we need to have them to be able to learn their environment. A bunch of ML stuff we won't get into, but we want to send them down there instead of people because we kind of don't really regenerate yet. We're still working on that. So we want to send them down there. So obviously as it detects data coming in, because these are sensors too, sensors sense our world, right? And then I need actuators to act on them, same concept as IoT. What I need to happen is I need to get this data in, and so I get a data that says there's, I don't know, lava or whatever it is, and then some model detected it. And obviously, I don't want the robot to step in it, but I need to navigate around because for whatever we're doing, we're digging for gold or whatever what they do. And so I'm not gonna know that when you build this. So typically parameters, you saw I actually put them in and whatever. How am I gonna know there's lava underground 300 feet or whatever it is? I'm not gonna know. So once that ML model processes that, I need a way to get data back into it so my algorithm can process to do something. That is called a parameter server. So I can literally have a parameter running, and you see the example is from a camera. I might have multiple cameras on there, and I might change the exposure based upon now I'm dark or light or whatever. How do I get this back into a running program that is not expecting a topic that says, camera exposure or lava? You can use these parameter servers and to do that. So you'll see it's like you have a node, there's some YAML file that says, as you detect things based upon some model, inference this and do something. So that's this concept of parameter servers. And so you can, if the parameter is there, true, if it's false, not, or you can determine the algorithm what to do with that. So I want to change the exposure because it's in this subterranean cave and it's really dark. I want to do something to it and handle it. And that's where the parameter server comes in, and you map this with these models. I'm very much oversimplifying it, but it sounds good out loud to say oversimplified, so we're going to keep going with that. The last thing that I showed you is gazebo simulator. So there's lots of these. This is the fun part. How many people play games? Oh, so I got gamers in here, but okay. So if I had come with a robotic game, it would have been cool. But okay, that's fine. Yeah. So what's cool about this is just like you play a game and you have the physics and the things with the game. That's exactly what you do with robots. And so the one of these is a gazebo, but there is a Unity. If anybody has programmed games, because I used to, that's a Unity simulator that does that. And this literally will simulate what we call worlds. What the new technology is coming out now is that I'm dynamically creating worlds simulations based upon where we are and being able to put robots in it so that it can actually interact in the real world. So this is one of the simulators. You're always going to have a simulator. You do not want to test, again, a robot or a car, for you Tesla fans who are still thinking that Elon, one who does know nothing about robots, but okay, is going to figure out the autonomous driving. He will not. Some other smart person will, but okay. This is, you don't want to put a robot, because that's what the cars are, the autonomous driving, into an environment that you haven't tested, because it's not going to detect possibly that you're a person in kind of a 2-ton thing hitting you off the road. You may not make it. So this is where the simulations become very important, even down to drones. If you know there's this big thing about the FAA allowing drones. We're literally developing right now, actually at Microsoft AirSim, a company we have within Microsoft, self-driving planes. Scary, right? But this is why the simulators become important. So this is what this is. And then the last thing you want to do is you want to visualize how this is going to interact in that simulation. So one thing is a simulation, and now I need to visualize what the robot is. So in that, let me go back to that really, really quickly, because I know we're out of time, but I just want to go back to this really quickly. So this environment, I didn't put a lot in there except for like a wall. So, I was going to have it hit the wall and you see what happened, but whatever. But there's just a wall in here. But you can put environment and other things up here, right? And based upon the environment being there, that is a gazebo. The robot that you see is running what we call the visualization. Sometimes you can combine them, and that's RViz. So, and I have these parameters in RViz that I could say, what if the robot was a little smaller? And so I can then change that and see what it would look like if I changed, the URDF with it. Now, that is not quite how you're supposed to do it, but you have some options to do that. What is a URDF? I just threw out acronyms. That's so horrible. How when you build a robot, it's just a YAML file that tells you how it looks. It has wheels. It doesn't have wheels. It's green. It's blue. It turns 3 yards or whatever. It's just what the physical aspect of the robot is. So this is gazebo running in here. And this is RViz running as well. And RViz has these parameters. So we're completely out of time. And I did not get to do any of the ML stuff that I really wanted to do because, again, I'm failing my class, so it'd be good to at least show you that I actually know what I'm talking about, but okay. The last thing I'll say is now we have robotics from our controllers. I know only people that are really into IoT are going to get how revolutionized this is. The fact that now I can put this small chip that goes in these light bulbs. Well, these are not really progressive light bulbs, but if you came to my house, every light bulb has a chip in it, and I just tell them to go off and on. So now if I wanted to, why would I make a light bulb robot? I don't know, I'll figure it out. But if I wanted to make something really small, a robot, I could now with your ESP8266, with these little chips that you have that are really maybe the size of my thumb. I can now control a whole drone, or I can have, what if maybe I should try this. Maybe if I put wheels on my Ring device, it can go around, the house and detect why the neighbor's cat keeps jumping on my furniture. Okay, I'm not salty. But, so I can now make a robot now out of even really small things. So this just came out with ROS 2. It now also allows me to control the individual robots. The last thing I'll say about this, which is not on here, which is my fun thing, is now I can quantize models. So ML models are huge. But now I can quantize models to run on devices that have maybe a meg of memory, and that's flash memory storage and everything else. So the world is really, really interesting right now. And the fact that I can do this not only with IoT devices, but robots is really cool. And so hopefully, next time we will not have these challenges and I can show you an ML model, but I will make a video of it because I do want you guys to see this running and having the ML model do something different with the different devices. So that's my time because I'm way over. And I'm sorry we had problems, but thank you for coming. Questions, you can ask me anything other than why am I failing my class that I
So, just to understand, so the gazebo sim already has these pre-built models for the existing commercial robots that we can do?
So you can load the models in Gazebo. So that, so there's a Ross index. It has a bunch of packages. There's Gazebo. It'll be like load these worlds. So there's some default worlds. You can build worlds as well. Yeah. Oh yeah. Think about it. If you're a Unity developer like I used to be, and you know how you build your world for a game, you can absolutely build a world for a robot, have it simulated in that world.